Alright everyone, so today we're going to be doing 10.7, which is going to be graphing trigonometric functions part 2. So this is part 2 because we already started this lesson in 10.6 graphing, but now we're going to be adding in another additional step to it. So we're going to be graphing cosine and sine functions that involve phase shifts. And also vertical shifts. So phase shift is another name for a horizontal shift. Okay, but in the graphing a trigonometric function, we call it a phase shift instead of a horizontal shift. But it's effectively the same thing. So like any function, trigonometric functions can be translated both horizontally and vertically. Translate just means shifted, right? You learn that in geometry. So like most functions, when we have a positive h, it actually shifts to the left. Does everybody remember how horizontal shifts are actually backwards in the sign? So same situation for the trig functions. And then a negative h actually shifts it to the right. So this is what a phase shift is going to look like. It's going to shift it basically some unit, some amount of radians. So in this case, this one shifts pi units, or pi radians, to the right because it's negative. And the bottom one shifts how many radians? What about B? What do you think?
4 pi?
Pi over 4, yeah.
Oh.
Radians to the, which direction do you think this one will go? Good. And then we have K, which shifts the midline up and down. So with a vertical shift, it's exactly as you expect. A negative goes down, a positive goes up. So in this case, this one shifts it 2 units up. So this function will shift 2 units up. What about the next one? It shifts it
4 units down.
Good, 4 units down. So is everybody good with the basic shifts? Okay, just identifying them, all that. All right. So putting it all together, let's talk about what each of these represents in the function and how they affect the function. So A affects the amplitude, and I'm leaving room because it also affects if it has a reflection. So amplitude and reflection are what's affected by A. So it's a reflection if the A value is what? Opposite of positive. This is negative. If your A value is negative, it's also reflected. This is your phase shift. So if this you want to write, if you want to write left is plus and right is minus, feel free to add that in. It's up to you. And this one affects your cycle, also known as the period, and that's your B value. And we know that the period is 2 pi divided by B. Feel free to write it or don't. It's on the next slide too. So what this means is a cycle is like its life cycle. Okay? So basically think of the function as if it's going through its life really quickly, passing all of its checkpoints, think of it as like critical points on the graph, aka like if you're on a timeline of your life, the critical points of your life. It's doing it really quickly. Or it can go through your life points really slowly. And the period and the cycle affect how fast or slow your graph is going to be changing what it's doing. And then the K value is going to be vertical shift. So up is plus and down is minus. And luckily, I feel like it's a lot more obvious with the vertical because it's as you would expect. Okay. So at times, the phase shift may be hidden. You may need to factor out the frequency, B, to isolate the phase shift. This is why your sine and cosine functions must be in the form A times sine of B times theta plus or minus H plus or minus K. So sometimes the B is going to be hidden and we have to pull it out. Okay, so see how in this form here we have a b value on the outside. We have to pull this one out. So there's a problem here. This isn't b. B needs to go outside of the parentheses. So what you need to do, and the easiest way to do this, is to identify the coefficient of theta, the number in front of theta, and divide everything in the parentheses by that term, or by that amount. So the first thing I'm going to do is I'm going to try to rewrite this in complete standard form. Now notice that this function doesn't have an a value, so what's the implied a value? 1. So it's going to be 1 times sine of. Now whatever the coefficient of the theta is, you're going to factor that out. So it's going to be 3 times. What's 3 theta divided by 3? Good, just theta. And here you're going to divide this one also by 3. So it's just going to end up being minus pi over 3. And then minus 1. So this is where we're at the form, and you know you're at the proper form because you'll be able to easily identify A, B, H, and K. So if you can't identify those just visually, you know that the graph isn't in its proper form. You need to get it to that form. So does everybody feel good about getting it into the proper form? Are we ready to try example 2? Okay. So over here, we're going to proceed the same way. Okay. So this is going to be y equals negative 5 times cosine of, this one already had an a, so I have to put it in. Now here I'm going to factor out a what? What do you think? Whatever the coefficient of theta. 2. So it's going to be theta plus. Now you have to take pi over 3 and divide it by 2. So when you take a fraction and divide it by a number, you basically just multiply the denominator by that. So it's going to be pi over 6. That's kind of a quicker way to do keep change flip. And then we're missing something. So we have an A, we have a B, we have our H, but what are we missing? So if the K isn't there, what is it? Good, just plus 0. So if you're missing a K, you can just assume it's a plus 0. So any questions on that part so far? All right. So on to the next slide. This is the same slide in your 10-6 notes. It's just talking about amplitude, period of the graph, the parent functions, finding the amplitude, finding the increment, and finding the midline. So we've already talked about this in 10-6. This is just a recap in case you need it again on your notes. So now we're going to just jump right in. So the first thing we're going to do is we're going to get it into its complete standard form. So y equals, we're going to make sure we have our a, which we do, times sine of. If we have a theta, we need to bring the b on the outside. So it's going to be 2 times theta. I just factored it out. But we don't have an h value here. So what's an h if you don't have one? Oh, I just factored it out of the theta here. So it really looks kind of like that. Does that help a little more? So if your graph was like, it was like this. Oh, is yours different than mine? Yeah. I'm sorry, I forgot for a second. See where the 2 came from now. So we're factoring out the 2, but in this case we don't have an h, so the h is just what? 0, and then minus 2 is the k. So this is A, B, H, and K. So we're going to go through and identify our key features. So amplitude is what? 1/2. Everybody good with how I got the amplitude? Phase shift is your h. So that's just 0. Period is 2 pi divided by b, which is what here?
2.
Good. Which comes out to be
pi.
Pi. Very good. So this means this graph has a really short lifespan. It's going to cover everything, all of its critical points, just from 0 to pi. So it's a little faster. And its increment is pi over 4. It's its period divided by 4. So increment means every pi over 4 units, this graph is going to have a critical move. All right, and I'll talk about how that appears on the graph. The midline is y equals k. And vertical shift is just whatever k is. So we like to wait on domain and range until we get a better view of our graph, okay?
How do you get the increment?
Sure. Increment is always the period divided by 4.
Okay.
Okay. If you forget that, it does. It mentions it on the step 3. So in case you ever forget, you can always look back there too.
Okay. Thank you.
So you're just using Desmos to graph this. You just type in the function. Sorry, I forgot to say it for the virtual.
Also, pi over 4 is between the 0 and the pi.
Exactly. And then we want something that's between pi over 2 and pi, which would be 3 pi? Let's see. 45, 90. Between 90 and 180. It's the same every time, so you don't have to worry about that. But it would be 135. So basically you're using the unit circle values that we came up with. The next one is going to be 3 pi divided by 4. That's going to be between pi over 2 and 2 pi. And then next one is going to be just pi. And then the next one, if we want to get really technical, is 5 pi over 4. And then 2 pi. Now, say you're confused about these intermediate values I pulled in. So I pulled in these ones that fall in the middle. If you're confused about that, there's good news for you, okay? If you're confused, the graph will tell you what they are. All you have to do is hover over it. So the graph does the work for you. You don't even have to remember that. If you just hover over the graph between 0 and pi over 2, see how it tells you it's pi over 4. If you're not sure, between pi over 2 and pi, just click. It'll show you.
You can use this for the last homework too, right?
Yes, the last homework also you can use this for 100%. So now that you have these table values, by just plotting your function on Desmos, I'm just going to take these values and plot them on my graph. So I had to move it over just for the sake of space, but I'm going to zoom out for a second here. And now I'm just going to graph everything. Probably better if I zoom in, huh? Sorry, I'm like indecisive about my zooming. So this is going to be at 0, -2, because that's what the table tells me, right? Pi over 4 is between 0 and 2 and pi over 2, which is going to be -1.5. So right here. And then at pi over 2, it's at -2. At 3 pi over 4, which is between these two, it's telling me -2.5. And then at pi, it's at -2. So once you have your snake shape, because this is what the shape of a general sign looks like, you know from here your graph's just going to repeat itself. So you can keep going with values, or you can just follow the pattern. And then you can graph your midline if you want, which is at y equals -2. So you see how it's right in the middle of the graph. Something I'll just say for anybody who wants to, know this. This is pi over 4 right here. This is 3 pi over 4. This is 5 pi over 4. And this 270 plus 360 divided by 2 is 7 pi over 4.
Could
So
you explain how you get the values for the table again?
sure, like the ones in the middle, you mean?
Mm-hmm.
Yeah, sure. So, do you remember the unit circle we did back a while
Yeah.
ago? We talked about like each one of those degree measures in each quadrant. Okay, so let me just talk about how this converts to degrees to maybe make a little more sense. This right here is 0 degrees. This is 90 degrees. This is 180. This is 270.
Mm-hmm.
And this is 360. So you're good with those values?
Yeah.
In radians. Okay. So then all of these are just values that occur between that. So between 0 and 90 would be 45, right between those two, because it's right in the middle. And then between 90 and 180 would be, so I take 90 plus 180 divided by 2, I can find the average. Is right between these, the exact middle of that is 300 or 135 degrees.
Mm-hmm.
And then right between 180 and 270 is 225 degrees. And then between 270 and 360 is 315 degrees.
Yeah.
So this is like if you're looking at the unit circle, we know that this is 0 degrees, 90 degrees, 180, 270, and then back to 360. These are like an angle that would fall right in the middle. So this is 45. This is, if it falls right in the middle, 135. This is 225. And this is 315. So it's like falling right between the two.
Yeah.
So each one of these, basically, like each one of those little like intermediate lines is actually a distance of 45 degrees, or pi over 4. Does that make a little more sense? Okay. I'm actually glad I explained that for the video, because a lot of students are probably going to be wondering about that. So, good question. So these values will be consistent on any graph. Sometimes you need them, sometimes you don't. So it is good to know them, or at least know how to get them. So now that we have that, let's identify our domain and range. So our domain is going to be from negative infinity to positive infinity. Now, on the graphs we had been doing n tends 6, usually our amplitude related to our range, but here something's a little bit different because my graph's been shifted down, it actually has changed. So my range is actually from negative 2.5 to negative 1.5. So the way you can always find the range is look at the lowest point and the highest point. Okay? And you're always dealing with y coordinates for range. So is everybody good with our first example? All right, we're going to move on to the next. We're going to look at this one. So before we get into any graphing, we're just going to get it into the proper format. So we're going to make sure we can identify A, B, and C, which is going to be necessary to figure out any of these things. So as you can see, I have an A value, an amplitude, which is -1, times. Now, what's really cool about this one is it already factored out the B for you. See how the B's already been taken out? So it did the math for you. So it's going to be 2 times theta plus pi over 2. But the only thing we're missing here, we have an A, we have a B, and we have an H. But what are we missing? Good. So if we don't have a K, it's just plus what? 0. Good. All right. So amplitude is the absolute value of A, which is 1. Now this being negative tells me I have a reflection, okay? So just keep that in mind. Now phase shift is indicated by H, but remember it's always the opposite sign. So this graph is actually going in the negative direction, pi over 2. Because remember, phase shift is always backwards. Now my period is 2 pi divided by my B, which ultimately comes out to be pi. My increment is my period divided by 4. My midline is y equals k. Vertical shift is just k. So is everybody at least good with getting these 6 identifiers? You feel comfortable with getting these? Okay. So now that we've done our identifiers, we're going to pull up Desmos, and we're going to put in our equation. And like I said, you can use x or theta, it doesn't matter. And everybody's able to find the pi button on the calculator keyboard?
Mm-hmm.
Okay, good. Just making sure. Some people were saying it was hard to find. So, now we're going to go to the table. And in my table, my increment is pi over 4, meaning I'm going to have to put in those extra values, okay? Those in between values. So that's going to be 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi divided by 4, and then 2 pi. So usually those values alone will give you enough of a view of what the graph's going to look like. You don't usually need to continue from there. All right, this is usually sufficient. All right, so if you get enough of these, you'll start seeing the pattern. Now you should have, do your values look like mine? Those of you graphing?
How do you get the values on the side, like on the right side?
This side?
Mm-hmm.
Those are generated by what I put in for x.
Really?
Yeah, is it not working for you?
No, nothing pops up on it.
So now that we have our table, I'm going to plot these values. So my table tells me we start at 0, 0. Then we move on to pi over 4 up to 1. And then we come back down to 0, down to -1, 0, and then once we see our pattern, we can just continue it. So that's what my graph's going to look like. And now I'll zoom out so we can look at our domain, which is -infinity to +infinity. And my range here is from -1 to 1. So does everybody see how I got the domain and the range here? Is everybody good with that? So we're going to be skipping letter C. I think that's the one we're going to skip, yeah. Yep, so we're going to be skipping letter C and letter D. So we're going to actually be moving on to E. And I'm going to skip those on your homework too, because those are too complicated. We're just not going to, we got one lesson left. We're not going to get too far into it. So we're going to skip C and D. If anybody is like ultra curious about this topic, you can always graph them on Desmo and see what it looks like if you want to. It's your choice. So let's rewrite this in proper form. So I'm on to E. Like I said, I was skipping C and D. So y equals my A value times cosine of. Now if you have a coefficient in front of your theta, you need to factor it out. So it's going to be theta minus pi over 2. Is everybody good with how I got that factored out? The 2. No, because it's technically, you know how cosine is a function of, you're putting it into cosine? This means that this is going inside the cosine function. Okay? Cosine is just an operation, kind of like multiplication division. And then it's going to be the minus the 2, or the 1. So this is A, B, H, and K. So we're going to identify our amplitude, which is the absolute value of A, which is 7/2, which is the same as 3.5. Now the period is going to be 2 pi divided by B, which is just pi. My phase shift is always whatever h is, but the opposite sign, so it's going to be a positive pi over 2. And my increment is always my period divided by 4. So these ones so far have had the same period, same increment, meaning every pi over 4 units, it's going to change. My midline is y equals k, which is -1. My vertical shift is k, which is -1. And then domain and range, we wait to see our graph. And yeah, we can't do that yet. So now we are going to graph this. Oh man, it's going to be a lot of... I was like hoping, because I'm like, there's going to be... So I typed it into Desmos. And then I hit this gear button right here, and I go to the table. And remember, in our table, we want to type in our trig values. So pi over 4, pi over 2, 3 pi over 4, pi, and then it would be 5 pi over 2, 3 pi over 2, and 2 pi. So I'm just typing those in. Now, like I said, if you for some reason, like say you mess this up and you don't type these in right, the graph like will guide you in a way. Like the graph will even like tell you like, hey, this is where you messed up. Like go back, find these values. You can click on them, the graph does it for you, which is really nice. I'm just going to exit these two out because they're kind of useless to us. Just so they don't throw us off. So now that I have my table, I'm going to plot this on my graph, okay? So see that you have the same or similar graph as mine. Is everybody good with that on Desmos? Now I'm just going to pull this over to the side so I can graph it on my own, but I'm going to be taking those values right from my table. So at 0, it tells me to start at 2.5, which is right here. At pi over 4, which is in the middle, it tells me to go down to -1. At pi over 2, it tells me to go down to -4.5. At 3 pi over 4, it tells me to go to -1. And at pi, it tells me to go back up to 2.5. Now here's the repeating pattern on my graph. You can see it now, what's happening. It's going to go down here, down, here, and up. Down, here. And then it's just going to do the same over here. Repeats the same pattern. And then we just graph this. This one's hard to graph. Here it is. The bigger is harder to do on this tablet thing. It's like so much concentration involved in this. Oh man. I'll get it in a second. Oh, thank you. So it's going to end up looking something like this. Now once we have it, we can identify our domain and range. Well, the good thing about these graphs is the domain is typically -infinity to +infinity because it goes in both directions forever. But the range is determined by its lowest and highest point, which is -4.5 to +2.5, Would you agree with that, the range, how I got that? Okay. So that is how you do E. And we're going to do one more graph together, which is going to be F, and then I'll give you some homework problems. And I'm going to take some problems off the homework too. So, F, we're going to zoom in. So I do want to practice one like this because it has everything going on. So we got the y equals 5/2 times sine of, we need to factor out that 2 right there. So it's going to be 2 times theta plus pi over 2. And then close the parenthesis plus 3. So is everybody good with how I factored out this 2 right here from the theta? Factored it out of both terms. Divide both terms by 2. Now that I have that, I can identify my amplitude, which is the absolute value of, which actually is 2.5 as a decimal. My phase shift is whatever's happening with h, and as you know, it's always the opposite. So this one's going in the negative direction, pi over 2. My period is 2 pi divided by b, which is pi, which makes my increment pi over 4. My midline is y equals k, which is 3. Vertical shift is 3 as well. And domain and range we're going to wait to see after we graph it. So is everyone good with these few indicators here? Okay. Now we're going to put it into Desmos. I'm going to pull it over here so you can see me type it in. You can type in the original or the modified version. So negative 2.5, same thing as 5 over 2, times sine of, well, sine 2 of, because we factored it out. Or you can leave it factored in if you want. Either way, it's going to work out. It's the same thing. Plus pi plus 3. So this graph's way up here, which makes sense. Why is it so high up for this graph? Anyone have a guess why it's above the x-axis? Has to do with k. What's your k value?
Plus 3.
Yeah, so it's been moved up.
Yeah.
Does that make sense? So now we're going to hit settings, table. I'm going to type in my usual values. 0, pi divided by 4, pi divided by 2. And like I said, if you miss any of these, it's not the end of the world because you can always see it on the graph and figure it out later. The graph will tell you if you're missing something important. Thank you. Pi hello. 3 pi divided by 2. We're on 7. So you have these values in your table, and I'm just going to be copying them onto my graph. So it tells me at 0, the graph's at 3. It tells me at pi over 4, my graph's at 5.5, so around here. At pi over 2, it's at 3. At 3 pi over 4, it's at 0.5. So like right here. And then at pi, it should be at 3. Yep. Comes back up. So you can start seeing its shape. And then just connect it. this is what your graph's gonna look like. The domain is negative infinity to positive infinity. And the range is from 0.5 or 1/2 up to 5.5. Does everybody understand where I got the range from? The highest and the lowest. So this is really all reliant on you just using Desmos and understanding these. And if you can do that, you're good to go.